All right, so looks like we're starting out with this chemical equation, this reaction. What is the problem? Let me see. Okay, all right. So if you do this reaction with, okay, 35 grams of this, 45 grams of oxygen. All right, and they want to know how many grams of carbon dioxide can be formed. Okay, so this is different in that instead of one being excess, you're given amounts of both of these, which means that one of them is going to be limiting and the other is going to be excess. It's kind of like, yeah, I like to think of it like a recipe. If you have like this much flour for cookies, but you only have this many eggs, you're not going to make more cookies than you have like eggs for cookies. It's that kind of idea. That one of them is going to stop. You're going to run out of one of these things, and that's going to determine how much you actually end up making. So the way to do this, there's multiple ways you can do it. What I usually do is I relate it to a product. So usually when you have your reactants and they tell you that you have like this many grams of this many grams of that, I want to see how much carbon dioxide that would create. So I'll just show you. So if we have 35 grams of C6H10, I'm going to turn this into moles. So 1 mole of C6H10 hexane is going to be 12.01 times 6 plus 1.01 times 10. Looks like we got 82.16 grams. All right. So I turned it into moles because ultimately I want to compare it to carbon dioxide. This is the step I'm doing right now is I'm finding limiting reactant. We want to see which one of these will run out first. So if I do this, I'll compare it to the carbon dioxide. Oops, sorry, not 1 mole. So we're using this for every 2 moles of C6H10. It's going to be 12 moles of carbon dioxide. And we're just going to leave it as that. I'm going to do the same thing for this one. 45 grams of O2 times 1 mole of O2 is 32.00 grams of O2. We turn it into moles of carbon dioxide. So for every 17 moles, 17, yeah. So for every 17 moles of O2, we have 12 moles of CO2. Okay. So just bear with me as I do this math. 82.16 times 12.2. Okay. So this one, yeah, we'll stick with that. So that one comes out to be that, and that one do the other one times 12 divided by 17. Okay. All right. 0.992. 0.99. I'll do it. 3. Okay, so this is what you have to do for finding limiting reactant. You have to turn both of these into the same thing so you can compare it. So in this case, I turned the 35 grams of C6H10 into moles of CO2. And I did the same with the oxygen. Basically, I just wanted to turn them into the exact same thing so I can compare them. Moles of CO2. If we look over here, this number is smaller. This means if we use up all the 45 grams of the O2, we're going to produce this much moles of CO2. And this means if we use up 35 grams of that, we're going to produce that much of 2.556 moles of the CO2. So obviously, if we start using up everything, we can only produce this much moles of CO2 because in a way it's our limiting reactant. You can kind of think of it like the fact is, since you produce less CO2 from this is like the maximum amount of CO2 maximum amount of CO2 you can create with the O2 you have. This means that you're gonna reach this amount of CO2, and then you're gonna completely use up all your O2, and then you're not gonna have any more O2 to combine with your C6H10 to make more carbon dioxide, because it's like just a quick little sketch. But if we have red plus blue, oops. If we have red plus blue, and it's like 1 red plus 2 blue is, I don't know, going to be equal to 2 purples. And we had 2 reds and 2 blues. Well, this tells us we need 1 red and 1 blue. So that's going to be, just going to shift this one over here. So when we use up this 1 red, let me do that another way. So when we try to add these together, we're going to end up creating some purples, because that's how this reaction goes. However, the thing that you can kind of imagine is that, this is basically what you have. 1 red and 2 blues creates 2 purples. That's what the reaction above states. Okay. But the problem is, you have 2 reds. So that means you're going to run completely out of blues first, because you need 2 to do it once. But you only need 1 red to go through with it. Which means you're going to use up all of your reds. Sorry, not your reds. You're going to use up all your blues. And you're going to be left over with this 1 red. So in this case, blue would be your limiting, because you used it all up. You can't make any more since you have no more blue. And red is going to be your excess, because you ended up with extra at the end, because you used up all your blue. So when you do this, all you have to do is take your 2 chemicals. You have to relate it to one of your products. So you could have chosen either CO2 or H2O over here. I just chose CO2 because in the end, that's what we're trying to find anyways. And you choose the smaller one. This means that I can only make 0.993. There's no way I'm ever going to reach this many moles of CO2, because I'm going to run out of O2 before I do that. So this means that O2 is limiting, and CO2 is excess. So what this basically means is now you can treat it like the problems before, where you were dealing with, where you were given like 45 grams of O2, and you're given like excess of C6H10, where you basically ignored it before. But now, you have to actually find out which one is excess and which one is limiting. So, this tells us that we're going to use up all of our O2, so that's the one we're going to be using. So we're going to find out how many grams of CO2 this makes. And I'm just going to rewrite it again so I can have the entire process in one thing and not have to round. But we're just going to be copying what's above, pretty much. So this tells us we're going to turn our grams of O2 into moles of O2. Then we're going to find out how many moles of CO2 we can make with that many moles of O2. Now we're going to look at how many grams that's going to be. So for every 1 mole of CO2, whoops. So for every 1 mole of CO2, you're going to have 12.01 plus 32, 44.01. 44.01 grams. So that's going to mean, when you do this math, it's going to come out to 45 divided by 32 times 12 divided by 17 times 44.01. It'll come out to 43.69 grams of CO2. And of course, if we're doing sig figs, we only have 2 sig figs, so that's going to be approximately equal to 44 grams of CO2. And that's it.